Um, it is a homework in chapter 6 for the random variable, right? So for any kind of random variable, we have to make the probability tree, probability table, right? So now, let me put the random variables of profit here with the probabilities here. How many kinds of profit here in this example? 2. Return 150 profit. We gain 150 profit. And what is the other one? Lose $700. Actually when we lose, it is not a profit, but random variable was a profit. So we have to say minus lose $700. It's minus profit, the lost. And we need the probabilities, right? What is a chance? We gain 150. 70%, 0.7. Then how much will be the lost?
30%,
0.3. Always, when we add up the probabilities for any kind of random variable, it should be 100%. To remember the summation in the probability trees at the end, in the last column, 100%. It is the same idea, right? In step number 1, we need the expectation. We need a mean. How? Take the value times the probability and then add them up. Take the sum. So now I can take 150 times 0.7. There's a negative sign. Please keep it up, right? It's negative 700 times 0.3. And then take the sum. The minus sign in front of 700, it will be subtraction. So can you do this for me? Die? Yeah. Do CPR.
I got a calculator already.
How much will be the summation? Actually, it is a subtraction. Negative 105.
Yeah.
Negative $105. What does that mean? If you buy the stock, we can expect we are going to lose $105. Don't buy it. It is not a good one. Okay. Anyway, expectation, it will be negative 105. Take the standard deviation. We have to apply the 6 steps. Already in step number 1, we took the mean. Additionally, we have to take, what we have to do in the second step? Subtract 1x minus mu. Please keep the sign. It's actually there was positive gain 150. Subtraction negative 105. Negative 700. Subtraction negative 105. Negative will be
positive.
Addition, positive, right? 255. Negative will be addition. Please help me. Negative 595. what we have to do in step 3?
Square.
What?
Square.
Take the square. Can you do 255 square? You know, we don't have enough time. So please do practice right now and right here. Okay, so please do it. 255 square will be
65,025.
65,025. 20.
Zero.
25.
0.25. Thank you. And how about the negative 595 square?
354,000.
54,000.
354,000.
0.25.
0.25 again. Okay. Now step 4. What I have to do?
Probability.
Times the probability. So 65,025 times 0.7. 354,025 times 0.3. So how much will be the first one?
45,000.
25,000.
40.
45.
45,000.
517.5.
Thank you. And the second one?
I'm doing it. Uh,
106,000.
106,000.
207.5.
207.5.
That is correct.
Thank you.
now you add them.
Thank you. Step 5. Take the sum. Let me see. 1,000, 725.
Yep.
Step 6. Finally. Just a second. Who is the sum?
Variance.
It is the variance. Thank you. Okay. Take the square root of it.
$389.
389.
89 point. Are we rounding? 52.
52.
Yeah.
Okay, let me try answer in my math lab.
Oh dear.
2 decimal place. Okay, it's nice. 389.52. Nice work.
Oh, good.
Yes, excellent. 6 steps. Can you remember? Right? You know, why not? Sometimes it's negative, right? You have to be careful. Negative subtractions, negative again. Just to keep it. From step 3, we are going to have a positive scores because we took square. Any negative values will be positive in step number 3. But before, please keep the sign every single time, carefully, slowly. Can you remember what we did last week? 6 steps to get the standard deviations. Okay, so please do the homework tonight, and I will give you another one today. Okay, chapter 6. I introduced to you the Bernoulli trials, uniform model, and briefly, I introduced to you what is the Bernoulli binomial model, and we discussed this one. Can you remember this example? Now, x was a random variable, the number of aces. The number of the aces. What is an ace in tennis? The successful first serve is ace, the number of aces. Can you remember what does it mean x equals 0?
None.
No success. All failures. Out of how many trials? Out of 6 trials. Right? So all 6 failures. How much was the probability? 1 failure. Point what? The probability of failure. 0.33, which was from 1 minus 0.67. So 1 failure, 0.33. But how many failures? 6. Can you do this again? How much was it?
0.0013.
0.0013. And I told you the player is not bad, was not bad. So all failures, it is a rare. Yeah, it's almost impossible. It's only 0.13%. Right? And the second one, x equal 1. What does it mean?
1 success.
Only 1 success. How many failures?
5.
5 failures. So take the probability, it will be 0.67. How many successes? 1. How many failures? 5 out of 6. But in this case, 1 success, only 1 success. So I can say success, failure, failure, fail, fail, and fail. Fail at first, success at second, fail and fail and fail. How many cases? 6 cases. Thank you. So we can multiply 6. Each of them will have the probability 0.67 times 0.33 with the power 5 times 6. How much will be the probability x equal 1? Please do it right here, right now. Anybody?
0.0026.
0.0026. It is a probability. Only 1 success. Good. One more time. X equal 2.
I don't think so. Do you have to multiply the 6 on that right there? Or is it
Yes, you have to.
just- I didn't do it. Yeah, it's, it's wrong then.
Times the 6, please.
0.0157.
0.0 again.
157.
157. Thank you. Because it is not the only case. We have 6 cases, but each case had the same probability. Simply times the 6. Right? X equal 2. How many successes?
2.
Thank you.
4 failures.
2.67.
Times
How many failures?
4.
4 out of 6. Now the problem is how many cases
6.
we are going to have? No, not 6.
Oh dear.
Look at this. No. Success, success. The first 2 serve, but fail, 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 and fail. Other case, success, first one. Second, fail, success, fail, fail, fail. Success, fail, fail, success, fail,
12?
fail,
It's like 30
12?
fail, success, success. Oh my god. Did you
32.
try? I asked you to try. No? Why don't you try tonight?
Huh.
Okay.
Yeah, you don't have to. But we have to know how many cases. You know, it is very simple. Only the first one, only the second one, only the third one, and the last one is only the last one is a success. One success, right? But the two successes, oh my god, success, success, here, 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 or here, 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 there.
37.
I can expect the last one is a fail, 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 but fortunately, the last two will be success and success, right? Simply we can just plug the two successes, 4 failures. It is easy. But the problem is, we have to know how many cases. 2 successes and 4 failures. It is the problem. So please go back to previous page. Look at this. Binomial model. Who was the P?
Probability.
P was the probability of success. What's the Q? 1 minus the probability of success. It is a probability of failures. You know, in the binomial model, like as the Bernoulli trials, we have only 2 outcomes: success or failures, head or tails, male or females, right? Only 2 outcomes. So look at this. Probability of success, 0.69. The power, x. What was the x? Number of successes. Number of successes, each case. Q, what was it? 0.33. Probability of failures. The power, n minus x. What was the n? Number of trials, 6. Minus, what was the x? Number of successes. Absolutely, out of 6, subtraction, number of successes, it will be the number of failures, right? So, 0.67 times how many successes, and that time is power, how many successes, Q, probability of failures, n minus x, how many failures, right? Now, the problem was, how many cases we are going to have. That is this one. Okay, the big parentheses. It is a problem. Oh my god. Do you know who is this?
Exclamation.
Excitement.
Oh my god! No.
Oh,
In math, it is a factorial.
meaning. Oh,
Please take out your calculator. Most of you have TI-84, right? Why don't you click 6? Please click 6. Go to the math. Go to the last column. You might have 5 columns. Please go to the PLB. PLB stands for the probability. So please go to the PLB, the probability.
Oh.
Number 3, there is a function, NCR. Please take it. The C function, NCR.
okay.
And plug 2. 15.
Okay.
We can expect 15 cases. You can try tonight.
What if you don't have an 84?
What?
What if you don't have
just
it?
have like a regular old calculator?
I will show you.
Okay.
You can try tonight, raining, chilly, in your room. Yeah, you can try. You will have a 15 cases.
Is this something you can download off the internet?
This one? Yeah, probably.
They have them on the school computers.
Oh, okay, cool.
But you can download somewhere.
Okay, cool.
I have no idea. Somebody did. I just use it. If you have TI 30 something, right? You have the PRB key here. You don't have to click a math. You don't have to go to the PRB. Directly, here is the key PRB. Why don't you plug the 6 and click the PRB key? And the second one, there is an NCR. Do you have any other calculator? You got it?
Yeah.
You don't know? Oh, it is a very good one, right? Yeah. It is the TI. Yeah, cool one. Number 3, combination. In your case, you have to take the function first. So go to the menu, probability, combination 3. It's actually the NCR, the C is the combination. So please take the combination, and in the parentheses you can put the 6, 2. A little bit different. Any other calculator? It is a PLB. You have a PLB key. Just a Now you have now you don't have it. The second. Probably. Let me tell you later. Anything else?
Hey, I got one. Let's see what you got.
What's that?
Let's calculate it.
Oh, but this calculator does not have the function C. Yeah. Anybody else? You got it? The PLB key, right? PLB key, right? Thank you. I will let you know. Yeah. Not all calculator, most of calculator, yeah, has the C functions. It is the combination. Returns how many combinations? 15. You can try it tonight. Yeah, you can have a 15 combinations. Okay? So please go to the math button, go to the probability, take NCR C combination function. Then you can take how many combinations for each. So please ignore whatever this one. Yeah, you don't have to. Okay? Good. So let me go to this example. Okay, now I can say what model? It will be the binomial. And the number of independent trials, 6. The P, probability of success. P, it is a 0.67. Now, we need a probability all 6 serves inbound will be inbound. So actually we need X, the number of successes, equal to 6. What was the formula? nx, the big parentheses for the combination, times p to the x, q, n minus x. How many n? How many independent trials? Thank you. How many x? How many successes? 6 again. Be careful. The first 6, it is n, which was number of trials. Second x, it is x, number of successes. Right? How much was the p, probability of success? 0.67. The power x, number of successes? 6. Thank you. The q, probability of failures? 0.33. And the power n, 6 minus 6. No failure. All successes. Right? Why don't you try take 6 NCR and 6, please. 6 and go to the math probability, take NCR and plug 6 again. How much it will be? 1, thank you. And how much will be the second term? 0.67 with the power 6. 0.0905. Thank you. And how much will be the value, the last term with the power 0? Always 1. The final answer? 0.0905. So I can add here. Yeah, we can take the probability x equals 3, x equals 4, 5, and finally probability x equals 6, all successes. Actually it was all successes, right? But how many combinations? 1 combinations. How many failures?
5.
Nothing. Right? Yeah, it will be 1. Please look at here. No successes. But actually we can add, we can multiply 0.67. How many successes? No success. How many combinations? F, 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 F. Only 1. Good, right? So always for any x, you can apply the probability function. Who is this? It is a binomial. It is a binomial model based on n, how many independent trials, and p, it is a probability of success. So please remember this one. P, it was the probability of success. N was the number of trials. The random variable x is actually, it was the number of success. It is the binomial model. Can you do that? It is the binomial model. It is random variable. What was a random variable? Random variable was a numerical variable. In chapter 3, we discussed what can we do with the numerical variable. We made histogram. Why not? We can make a histogram. In Excel. I love Excel.
I don't.
Let me put n, number of trials, 6. And here is the probability of success, 0.67. And the possible values for random variable, number of successes, no success, 1 success, 2, 3, 4, 5, up to 6. Because we serve only 6 times. You know, Excel is not only for statistics, but it is good for statistics when you go to function and statistical functions. A little bit going down, you have a function, it's a binom.dist. It is the binomial distribution. Let me take it. We need the number of successes, yeah? Number of trials, n, probability of success, 0.67. I don't need the cumulative probabilities, so just to say false. 0.00129. Look at this. How much was it? 0.0013. It's actually, it is 129. I'm sorry, you cannot bring your laptop in this using small calculator. Take the C, right, times. Okay, let me copy down. Let me copy down. Can you see the second one, x equal 1? How much was it? X equal 1, 0.0157. I did it. Yeah, it is 0.07985. And the last one we did. How much was it? 0.0905. Yeah, your answer is 0905. Yeah, it is, right? It is the binomial model with N6, probability of success 0.67. Let me make the histogram. Take the probabilities. Just a second. When I take the summation of 7 probabilities, how much do you expect the sum? Thank you. Why not? And take the 7 probabilities, make the histogram. It's not exactly this histogram, but please excuse me. There's a space between the bars. It is not from 1 to 7, it's actually, it should be from 0 to 6. Let me select and change from 0 to 6. Who is this? It is the binomial. It is the binomial model. And it is the histogram. Take the mean. Because it is a numerical variable. Why not? Mean, center. How do you think? 3? Is a 3 in the middle? It is the mean. Yes? No? Because here is a little bit more weight. Yeah, when I comparing from 0 to 6, the value 3 just in the middle, but there is a probability. Probably the mean, the center, is a little bit higher. A little bit higher than 3. How about 4? A little bit lower? Why? Because it is more than this one. It is more than that one. But there is a little bit more, even though it is almost 0, but it is nothing. It is not nothing, right? So do you expect a little bit less than 4 or bigger than 4? Less than 4? Less than 4? We can try. Yeah, we knew it. We knew how can we take the mean expectation. How? Value times the probability, the value times the probability, and then take the sum. Let's try. The value times the probability, the value times the probability. So let me copy down, and then take the sum. 0.00129. 4.02. I think it is nothing. It is nothing relatively. Yeah, here is a little bit more than here. So the center is a little bit above 4.02. So it is the mean, it is the center. Why don't you take the standard deviation? Apply the 6 steps. Take the difference, take the square, times probability, sum, divided by, I'm sorry. No, not divide, yeah. Take the square root to take the standard deviation. 6 steps to take the standard deviation. Yeah, let's try. Take the difference in the second step, x minus the mean. Copy down. Take the square. Times the probability.
I see why you like Excel.
Yeah. Do you love Excel? Yeah. And let me take the sum. Who is this?
Variant.
The variant. Thank you. Yes, it is. And take the square root of the variance will be the standard deviation. Good. I apply the 6 steps. Take the difference, take the square, times each probability, sum, it will be the variance, square root, it will be the standard deviation. Good? Right? Any question? So far so good?
Yeah.
Can you try n times p?
No.
How many n? Number of independent trials. How many trials? 6. P. Probability of success. 0.67. Take the multiplication. 6 times 0.67. Yeah, using your smartphone if you don't have your calculator.
4.02. Mean.
Say again?
The mean. 4.02.
4.02. It's magic. We don't have to. We don't have to take the multiplication, no. Simply just take the multiplication, how many n, how much was the probability of success. N times p, it will be the mean. It's a secret. Why don't you try n times p times q? Who was the q? 1 minus the p. Probability of failures, 0.33. 6 times 0.67 times 0.33. How much will it be? 1.3266. We don't have to apply the 6 steps. It's a magic. N times P times Q, it will be the variance. Finally, additionally, take square root. It will be the standard deviation. You know, when I introduced you the Bernoulli trials, uniform model, I told you in statistics we have a many suggested common random variables. We knew everything. Okay? The binomial model, we knew how can we take the probabilities, how much will be the mean, and how much will be the standard deviation. Developed, done, given. Very easy ways. Just n times p, just square root of n times p times q. It will be the mean, it will be the standard deviation based on the binomial model. It's very easy. We don't have to. We don't have to. But generally, we can take the mean, we can take the standard deviations. But in the binomial model, very simple. N times p and square root of n times p times q. Let me change. I didn't click enter yet. When I change the probability to 0.9, how much will be the mean? Can you try 6 times 0.9, please? 5.4. You know, on this histogram, the mean was 4.02. But when I change the probability, 6 times 9 will be 5.4. Say again?
Would that be the third quartile in this histogram?
No. So the new mean will be 5.4. What do you expect? The shape of the distribution. Is it move to? Right, yes. How about plug 0.2? Can you try to take multiplication 6 times 0.2? How much will be the mean? 1.2. What do you expect? The shape of the distribution. Go to left. It is easy to expect what happened because mean was simply n times p, and the mean was a measure of the center. So it's move to left, move to right. Depends on the mean, depends on the p, probability of success. It is the binomial model. Any question? We are going to do the practice in the quiz today using the binomial later. And the next one is a possum. Oh my god. Yeah, another function to get the probability, right? Okay, let me review the binomial. It's actually in this example, the random variable x was. Can you see here? The number of something, right? The Poisson model, can you see the x there? Number of something again. It's the same random variable. It was the number of something. Now, in the Poisson model, it is a number of something again. But let me ask you, how many texts do you receive? Do you receive in a day? How many texts? 5.
My mom.
From your mom? Yeah, I'm too. A couple of texts from my wife.
Yeah.
Yeah, take something.
Don't
Come
forget to
home,
wash my
right?
clothes.
Yeah, buy some milk. How many texts in a day?
2.
We're not popular, I guess.
We just
Yeah, we are
family.
not. Yeah, I understand you. How many texts?
About the same.
Same?
That's what these young
Why
kids-
not?
Ask the young kid.
How many? You.
Okay, well, I mean, all my kids' stuff is social. I'm at least 100.
At least 100?
Yeah, because all of their school activities and everything automatically doubles.
Good.
Yeah, I get 10 just from them.
How many?
Maybe
1?
20.
Oh, 20. Yeah, almost better. Right?
We need to
How many phone
text
calls?
each other.
How many phone calls in a day?
Time slips.
Yeah, these days is many of you the texting is not phone calls, right? Can you tell me how many car accidents in a week in Fort Smith? Today is raining, right? How many times do you expect?
15.
15 a week? How do you think it's a snowing day, snow day in winter?
Probably.
Probably it's more 20. Who knows? It's more than 100. Sometimes it's more than 1,000, right?
They haven't learned yet.
You can have a more than 1,000 texts someday, right?
I
Yeah.
don't know
Why
this
not?
one.
Yeah, we can do it.
I wouldn't want 1,000 texts. I wouldn't bother my phone.
No.
Look at this one. In this example, the tennis player tried 6 times, right? Number of successes? Only up to 6. When I toss one coin 10 times, can I get 12 heads? No. Up to 10. Toss 20 times? It's up to 20, right? But when I ask you how many texts? Yeah, 4, 5, 2, 1, 120. Can you tell me the limit? The maximum number of texts in a day? Maybe 1,000. Right? You know car accidents? Snow day? Raining day? Who knows? It's more than 1,000. We cannot determine the limit. You know, binomial model, Poisson model, random variables, the number of something. But we can say the limit, we are going to use the binomial model. No limit, it is a Poisson model. Yeah. It looks same, but totally different. There is a limitation up to 6, up to 10, up to 20, but Poisson model, there is no limit. But it begins from 0. No success. No head. Same thing, because it is a number of something. So it's a no text, right? It's a no accident, right? But it's going to infinite. So please look at this example. I have a online shopping mall, shopping site. On average, I had 3 customers in a minute. On average. Yeah, 3 customers bought something in a minute, right? When I post something, eBay, I can tracking, I can expect 3 people visited my website in a minute, right? It's the same thing. Always 3 customers in a minute, sometimes 5, sometimes no customer between 2 to 4 a.m. Who knows, right? But it could be more than 100 customers, more than 1,000 customers on the Black Friday, right? Who knows, right? We cannot determine the limit, but on average, 3 people in a minute. Does it make sense, right? So we cannot say the possible maximum number of customers. It is not the binomial model. We have to use the Poisson model for the random variable number of customers. Does it make sense, right? So that will be the probability model. And now we need the it's another Greek letter. It is the lambda. And it is the mean. I told you any kind of given common random variables in statistics, we knew everything. Who will be the mean? Who will be the standard deviation? the standard deviation will be square root of lambda. Just a second. Who was inside of the square root sign? It was a variance. Who was a lambda then here? Variance. Lambda was the mean. It is very funny. In the Poisson model, the mean and the variance are same. It is very interesting. The mean and the variance, they are same as the lambda. And we need a lambda to get the probability. In this way, we are going to take the probability. E to the lambda, the mean. Just a second. What was the E? Do you know what is the E? It is an exponential function. Why don't you try to look for E on your calculator? So just to take E. When it asks you the power, just plug the 1. So please just take E power 1 and enter. How much is this? 2.1
2.718
Keep going.
281828.
Do you know what is a pi? Pi
3.19
3.14
14.
15
2.6.
926 7 4 6 1 2. Just kidding, I don't know. You know the E is kind of like as the pi. You know the pi is 3.14 right? It is almost. Can we call this one is a irregular number? Whatever. Yes.
Why use the first power give me E?
The first power, the E to the 1. Yeah. It's the same thing. E is a constant. The endless one is a 2 point something. Pi was 3.14 and something, right? It's the same thing. Never mind. We have a calculator, right? Just to take the E and just to put the power negative the mean lambda. Please look at this one. What's the model? No limit. We are going to take the Poisson model. We are going to use the Poisson model. You know, actually it is not a Poisson. It's a French. It is the name of the French statistician, Poisson. He suggested the Poisson distribution. And the mean lambda equals 3 in a minute. 3. So now, here is at least 1. Today, I want to try to get exactly 1. Okay? The probability, x equal 1. What was the formula? E to the negative lambda, lambda power x over x, factorial, I'm sorry. How many lambda was? The lambda was the mean. How many average in a minute? Lambda was 3. How many x? How many customers to get the probability? X. 1 purchase, thank you. And 1 factorial. Can you tell me how much will be e to the negative 3? Using your smartphone and the flip this way, then you might see the function of e. You can try.
You want all those numbers?
Give me for decimal places.
0.0497
497
8
8. That's it.
7
And
Okay.
And how much will be the second term? 3 with the power 1 itself, 3. Okay, finally, factorial. Oh my god. Please go to the place where you got NCR.
Oh.
So you have TA84, you have to click the math, go to the column PRB, probability, and the very next one, there is a factorial.
4.
So how much will be 1 factorial? You have to plug 1 first
Oh.
and take the factorial. How much will be 1 factorial? 1. Yes, thank you. So how much will be the probability? 0.0498 times 3.
0.1494.
0.1. Say again?
1494.
No.
0.2988.
0.12. Oh, I'm sorry. 14. You're right. 14.
You betcha.
I'm sorry. I'm so sorry. Please. Please give me 2 more decimal places. Please,
Yes.
please. 1494.
94.
Thank you.
Thanks for playing.
It is the probability. For what? We are going to have only 1 customer in 1 minute. Less than 15%. Why? On average, we had 3 customers in a minute. On average. Only 1, less than 15%. Probably we can expect it's more than 1 because we had 3 customers on average. Does it make sense? Yes.
So we got the one off the X for the lambda because each one's independent. So how-
What?
I'm confused.
The 1?
How we got the second part of that?
The second part?
Yeah.
Because he put X
There is
was
a
1.
lambda to this one.
Like how we got that there was just one person, one
Yeah.
customer.
That's mine, but go
Is
ahead.
yours okay? Thank you.
What is
The probability.
Look at this.
Oh, okay.
Lambda 3 x 1.
Okay.
And this one, E here, negative, lambda was 3.
Okay.
I just plug here and there to get the probabilities. Okay? The Poisson model had another probability function, another mean, and another standard deviation. But the mean and the variance are same as the lambda. We need a lambda to get the probability. Lambda is on average. It is the mean. Do you have any other questions?
Can you explain that last part of the factorial part again? I didn't catch it. How'd you do it? How'd you plug it in the calculator?
What is your calculator? This one?
Yeah.
You can click 1. You can click 1 first.
Hitman. Hitman.
If you have this one, click 1 first. Math, probability, and number 4. We took number 3 in the binomial model, NCR. But now we need a factorial, number 4. Take it, and answer is a 1. Yeah, very simple. It is very simple. Yeah, you spend so almost $100 for your calculator, right? You have to use it. Why not?
Knowing is half the battle.
We are going to finish chapter 6 on Thursday.
Okay.
And we are going to do chapter 7 on Thursday too. So here's a quiz number, I think, number 9.
8?